acid. Its formula is H2SO4. It is manufactured by the contact process. The acid produced by this method is free from arsenic impurities and hence can be safely used for the preparation of edible products. The manufacture of sulfuric acid by contact process involves the following steps. First step is the production of sulfur dioxide by burning sulfur or roasting iron pyrite. This is iron pyrite FeS2. If we carry out the roasting of FeS2, it forms iron oxide and sulfur dioxide. And next step is catalytic oxidation of sulfur dioxide by air to give sulfur trioxide. And this is in accordance with Le-Chatelier principle. There are following favorable conditions for the maximum yield of sulfur trioxide, that is high pressure, low temperature, use of catalysts like vanadium pentoxide or platinum, purity of gases, excess of oxygen for the maximum yield of sulfur trioxide. And next is the absorption of sulfur trioxide in 98% sulfuric acid to form oleum, that is H2S2O7. And on dilution of oleum we get desired concentration of sulfuric acid, and these two steps are used by the industries to produce sulfuric acid from SO3, sulfur trioxide. Next is properties of sulfuric acid. These are physical properties of sulfuric acid. First one is pure concentrated sulfuric acid is a colorless syrupy liquid. It is also called as oil of vitriol. Second, it has a density of 1.84 at 298 Kelvin. It boils at 590 Kelvin and freezes at 283 Kelvin. It is highly corrosive and produces burns on skin. That's why while using in laboratories we always wear gloves. Next, it has a high boiling point and high viscosity because its molecules are associated due to intermolecular hydrogen bonding, strong bonding, and strong bonding requires more energy to break. That's why its boiling point is high and high viscosity. It has a strong affinity for water. When sulfuric acid dissolves in water, a large amount of heat is produced because it is an exothermic process which may spurt the acid out of the container. Hence, care must be taken while preparing dilute sulfuric acid from concentrated sulfuric acid. Therefore, concentrated sulfuric acid is always diluted by adding the acid slowly into water with constant stirring and not by adding water to the acid. We always prepare dilute sulfuric acid by adding acid slowly to the water, not water to the acid, because it is an exothermic reaction. It produces large amount of heat which may spurt the acid out of the container. Next is the chemical properties of sulfuric acid. First one is acidic character. In aqueous solution, H2SO4 ionizes in two steps. In first step, H2SO4 ionizes to form H positive plus HSO4 negative. And in second step, HSO4 negative dissociates to form H positive and SO4 2 negative. Thus, H2SO4 acts as a strong dibasic acid because it has two replaceable H positive ions and form two series of salts, that is normal salts like sodium sulfate and hydrogen sulfates or bisulfates such as sodium bisulfate like NaHSO4. Being an acid, it neutralizes alkalis to form salts and water and decomposes carbonates and bicarbonates. For example, sodium hydroxide when reacts with, this is an alkali, when reacts with sulfuric acid, it forms sodium bisulfate plus water. And in case of sodium carbonate, when sodium carbonate reacts with the sulfuric acid, it decomposes to evolve CO2 and water plus Na2SO4, sodium sulfate. It reacts with the active metals like zinc, magnesium to evolve hydrogen gas. When zinc reacted with the dilute H2SO4, it forms ZnSO4 plus hydrogen gas is evolved. You have already read this reaction in the 10th class, in which the zinc granules are treated with the dilute sulfuric acid and the hydrogen gas is evolved, and which is determined by the pop sound. Next, it is a dehydrating agent. Concentrated sulfuric acid has a strong affinity for water and hence it acts as a strong dehydrating agent, in which it removes water from the molecule. For example, in case of chairing of sugar, when sucrose is treated with concentrated sulfuric acid, it changes it into carbon plus water, and this carbon is sugar charcoal. Next is the dehydration of formic acid. This is formic acid HCOOH. When it is treated with concentrated sulfuric acid, it forms water and carbon monoxide. It also acts as an oxidizing agent. Hot concentrated sulfuric acid is a moderately strong oxidizing agent, since it on decomposition gives nascent oxygen. Its oxidizing power, however, lies between nitric acid and phosphoric acid. When sulfur reacts with sulfuric acid, it oxidizes it to sulfur dioxide, that is SO2 plus water. And when copper turnings reacts with concentrated sulfuric acid, it converts into copper sulfate and SO2 gas is evolved, and water also. It also oxidizes phosphorus to phosphoric acid, carbon to carbon dioxide, etc. Next is the action on salts. Because of its low volatility, concentrated sulfuric acid can be used to manufacture more volatile acids from their corresponding salts. A dilute acid like sodium thiosulfide plus dilute H2SO4, it gives Na2SO4 plus sulfur dioxide plus water plus sulfur. Next is the precipitation reaction. When aqueous solution of barium, strontium, calcium, etc. salts are treated with dilute H2SO4, white precipitates of their corresponding metal sulfates are formed. For example, in case of barium chloride, when it is treated with dilute H2SO4, it forms BaSO4. It means a salt of barium, that is barium sulfate of, it forms white precipitates of barium sulfate, and this arrow indicates the precipitation plus 2HCl. Similarly, in case of lead acetate, when it reacts with dilute H2SO4, it forms lead sulfate plus acetic acid, and lead sulfate is in the precipitated form. Next is the miscellaneous reactions. Here it is the action of potassium ferrocyanide. When potassium ferrocyanide, this is potassium ferrocyanide, when it reacts with H2SO4, dilute H2SO4 plus water, it forms K2SO4 plus FeSO4 plus ammonium sulfate plus carbon dioxide. Here carbon monoxide is formed, it is carbon monoxide. When potassium ferrocyanide reacts with sulfuric acid, it produces carbon monoxide. Next, when sulfuric acid reacts with PCl5, it forms chlorosulfonic acid plus POCl3 plus HCl. It depends upon the amount of PCl5. If we double the amount of PCl5 and reacts with the sulfuric acid, it forms sulfuryl chloride. Its formula is ClSO2 Cl plus 2 POCl3 plus 2HCl. When KClO3 potassium chlorate is reacted with hot concentrated sulfuric acid, it gives chlorine dioxide with explosion. That is KClO3 plus sulfuric acid, it gives KHSO4 plus HClO4 plus 2ClO2 plus water, and due to this gas, evolution of this gas, this reaction becomes exothermic. Next is oxo acids of sulfur. First is H2SO3 sulfuric acid, in which sulfur having a lone pair of electron and attached to two OH groups and one oxygen with double bond. It is dibasic due to the presence of these two OH groups, because these are replaceable OH groups, and its oxidation state is +4 in sulfuric acid. Next is sulfuric acid. Its formula is H2SO4. In this case, sulfur is present in +6 oxidation state, in which sulfur is attached to two OH groups and two oxygen with the double bond. Here, due to these two OH group, it is a dibasic. Next is peroxo disulfuric acid. Its formula is H2S2O8, in which there is a bridge of oxygen between the two sulfur atoms, and it also have two OH groups. That's why it is a dibasic in nature, and sulfur is present in +6 oxidation state. And next is pyrosulfuric acid or oleum, H2S2O7. Here sulfur is also present in +6 oxidation state, and there is one oxygen between these two sulfurs forming a bridge, and two OH group. That's why it is dibasic and attached to the 4 oxygen atoms with the double bonds. Next is thiosulfuric acid. Its formula is H2S2O3, and here the sulfur is present in +6 state and this sulfur in -2 state. And next one is dithionic acid. Its formula is H2S2O6 and its oxidation state is +6, in which the sulfur and sulfur is directly linked to each other by a single bond, and the 4 oxygen atom with double bond and 2 groups with OH bond, one single bond. Next is Carros acid or peroxomonosulfuric acid. Its formula is H2SO5. Here sulfur is present in +6 oxidation state, in which the sulfur is attached to OOH group. This is a peroxo group. And peroxo disulfuric acid is also called as Marshall's acid.